You're listening to Full Circle Weekly News. These articles are compiled by Eric the Unready, and I'm your host, Moss Bliss. This is episode 370, covering week 23, June 3rd through 9th, 2024. The Mate 1.28 desktop environment has been officially announced, continuing the development of the GNOME 2.32 codebase while maintaining a classical desktop layout. The announcement on the Mate project website appeared March 6th, but before that, a clear announcement of the release and without the publication of the general list of changes was not seen. Packages with Mate 1.28 are already available in distribution repositories such as Fedora 40, Gentoo, Mageia, Manjaro, OpenSUSE Tumbleweed, Arch Linux, Alt Linux, Artix, OpenIndiana, GhostBSD, Parabola, Solus, and Void Linux. Andreas Kling announced the removal of the powers of the Benevolent Dictator, BDFL, of the Serenity OS project and the switch to development of the fork of Ladybird web browser, which previously deployed as part of Serenity OS. For the last 2 years, Andreas has been detached from the development of the operating system and was focused only on the development of the browser engine and the Ladybird application based on it. Since a strong community is formed around Serenity OS, numbering more than 1,000 participants unable to do without him, Andreas decided to switch entirely to the development of the Ladybird browser and its promotion as self-sufficient and independent of the Serenity OS project. After the separation, the developers of the Ladybird browser will stop supporting Serenity OS and focus on the development for Linux and Mac OS platforms. The developers of Serenity OS will be able to return to the original model of development for pleasure, communication with like-minded people, and as a hobby. Unlike Serenity OS and the Ladybird project, restrictions will be removed that ban the use of third-party code in the project. Ladybird's old repository is transferred to archive mode. FreeBSD 14.1 has been released. Installation images are prepared for AMD 64, i386, PowerPC, PowerPC 64, PowerPC-S, ARM-PE, ARM-v7, AArch64, and RISC-V64 architectures. In addition, builds for virtualization systems and cloud environments are prepared. Canonical has released Ubuntu Core 24, a compact version of the Ubuntu distribution adapted for use on Internet of Things devices in containers, consumer, and industrial equipment. Ubuntu Core comes in the form of an indivisible monolithic image which does not break down into separate deb packages. Images of Ubuntu Core 24, which are synchronized with Ubuntu 24.04, are prepared for x86-64 and ARM64 systems. The announcement also covered support for RISC-V, but the builds are not yet available. The time for supporting the release will be 12 years. Ubuntu Core serves as the basis for the launch of additional components and applications which are designed as self-sufficient add-ons in Snap format. Ubuntu Core components, including the base system, the Linux kernel, and system add-ons, are also supplied in Snap format and managed by Snapd tools. Snappy technology makes it possible to form an image of the system as a whole without parting into separate packages. Instead of a phased update at the level of individual deb packages in Ubuntu Core, the mechanism of atomic update of Snap packs and the base system is used, similar to Fedora Atomic, Chrome OS, Endless, and OpenSUSE Leap Micro. When updating the basic environment and Snap packs, it is possible to revert the state to the previous version in case of problems identified after the update. To ensure security, each component of the system is verified by digital signature, which allows you to protect the distribution from getting hidden modifications or installing unverified Snap packs. The components supplied in Snap format are isolated using AppArmor and SecComp, which creates an additional layer to protect the system in case of compromising individual applications. The basic system includes only a minimum set of necessary applications, which not only allowed to reduce the size of the system environment, but also had a positive effect on security by reducing possible vectors for attacks. The base file system is mounted in read-only mode. You can use data encryption on the storage using TPM. Updates are released regularly, delivered in OTA mode, and synchronized with the composition of Ubuntu 24.04. To minimize traffic, updates are delivered in a compressed form and include only changes relative to the past update. Automation of updates solves problems with maintaining the system's security when used on embedded devices. Nitrux 3.5.0 has been published, built on Debian, KDE Technologies, and the OpenRC initialization system. The project offers its own NX desktop, which is an add-on over KDE Plasma. Based on the MAUI library for the distribution, a set of typical user applications are in development, which can be used on both desktop and mobile devices. App Images is being promoted to install additional applications. The project is distributed under free licenses. The NX desktop offers a different style design, its own implementation of the system system tray, notification output center, and various plasmoids, such as a network connector and multimedia applet to control the volume and control the playback of multimedia content. NXS Backup 3.7.0 is out, which allows you to backup, rotate the backups, and store the backups on local or external storage. In addition to the file backup files, you can also create backups of various DBMSs, MySQL, PostgreSQL, MongoDB, and Redis. The project code is distributed under the Apache 2.0 license. Backups can be stored both locally and in remote repositories for which various libraries are used. Thanks to the mini framework Go-NXS-AppCTX, you can use the environment variables in the configuration. Backup can be done not only for the specified period of time, but also taking into account the maintenance of a specific number of backups. There is a self-renewal function and the ability to expand the functionality through custom scripts. The developers of FFmpeg announced their own implementation of the decoder for the XHE-AAC, Extended High Efficiency AAC, sound encoding format, defined in the ISO/IEC 23003-3 standard. The XHE-AAC decoder has already been adopted in the main codebase of FFmpeg and will be included in the next release. The implementation can be used for most XHE-AAC stereo streams. The streams of SBR and USAC are to be added soon, and MPEG-H with surround sound, as well as speech coding, are not supported yet. XHE-AAC is used in Netflix streaming and is involved in digital radio broadcasting, Digital Radio Mondiale. The codec is notable for the support of a wide bitrate range, high compression, constant volume reproduction, high volume, high deficit at all volume levels, additional dynamic range control profiles when listening to noisy places, and adding metadata that allows you to restore losses on the receiving side. Developers from the KDE project presented Clever Notes 1.0, yes, it's spelled with a K, which is written using the Kirigami framework and can be used on both desktops and mobile devices. When writing notes, they propose you use Markdown language. The result is then immediately displayed in the preview area. In addition, to-do lists and pasting simple drawings with lines are supported. Notes can be placed in a hierarchical form, broken down into categories and groups. The functionality of the application expands through plugins. For example, plugins are available for linking different notes, highlighting syntax, fast insertion of emoji, and creating diagrams using the plant UML markup. The style of preview of text in Markdown format can be changed by the user using CSS. The OpenSSH team added protection against automated password attacks where bots try to guess the user's password by entering various typical combinations. To block such attacks, the per-source penalties parameter has been added to the SSHD_config configuration file, which allows you to determine the lock threshold that works with a large number of failed connection attempts from one IP address. The new protection mechanism will be part of the next release of OpenSSH and will be included by default in OpenBSD 7.6. When you turn on protection, the SSHD process begins to track the completion status of child processes, determining situations where the authentication has not passed or when the process has been accidentally completed due to a failure. The high intensity of failures in authentication indicates attempts to guess passwords, and emergency completion may indicate attempts to exploit vulnerabilities in SSHD. Through the per-source penalties parameter, a minimum threshold of anomalous events is set. After exceeding that, the IP address where the suspicious activity is coming from will be blocked. With the per-source net block size parameter, you can additionally define a subnet mask to block the entire subnet to which the problematic IP belongs. To disable the locking for individual subnets, the per-source penalty exempt list parameter is proposed, which can be useful in situations leading to false positives. For example, when the SSH server is accessed from a large network, requests from different users from the same IP or proxy. The GNU project has unveiled Thaler 0.11, a free electronic payment system which provides anonymity to buyers but retains the ability to identify sellers to ensure transparency in tax reporting. The system does not allow you to track information about where the user spends money, but provides means to track the receipt of funds. The sender remains anonymous, which solves the problems with the tax audit inherent in Bitcoin. The code is written in Python and is licensed under AGPL v3 and LGPL v3 licenses. GNU Thaler does not create its own cryptocurrency but works with existing currencies, including dollars, euros, and bitcoins. Support for new currencies can be ensured through the creation of a bank that acts as a financial guarantor. The business model of GNU Thaler is based on the execution of exchange operations. Money from traditional payment systems such as Bitcoin, MasterCard, SEPA, Visa, ACH, and SWIFT are converted into anonymous electronic money in the same currency. The user can transfer electronic money to the sellers, who can then change them back to the real money presented by traditional payment systems at the exchange point. You've been listening to Full Circle Weekly News. For more details, see the next issue of the magazine at fullcirclemagazine.org or check the links in the show notes. You can contact me at bardmoss@pm.me. I'll see you next week.